speed limiter, cruise control, navigation system, mobile phone. Nowadays, these in-vehicle technologies, or IVT, are part of drivers' everyday life. Although they are available in more and more vehicles in Europe, they are still poorly understood and prompt many questions. Who is using them and who is not? What are the motives to use the systems? In which context do drivers use them? How do they interact with them? What are the real effects on driving? And what are the differences between European countries? For more than 4 years, European experts have been studying driver interactions with these technologies. This is the Interaction project.
Interaction is the first European project aiming to understand driver interaction with in-vehicle technology. We focus on mature technology, that means technology already available on the European market. And the innovation of the project has been to implement a comprehensive research approach, including 4 methodology: focus group, questionnaire survey, naturalistic observation and in-depth observation. We collected both quantitative and qualitative data, and we investigated driver behavior with self-report made directly by the driver, but also by the observation of their behavior in everyday life.
The focus group interviews were designed to collect as many drivers' opinions as possible about IVT use, in order to validate, refine and extend the research hypotheses.
L'étude cherche à comprendre comment les conducteurs utilisent les nouvelles technologies à bord des voitures. Et le but de cette rencontre ce soir, ça va être de recueillir votre opinion sur 2 systèmes en particulier, qui sont le GPS et le téléphone portable.
This preliminary was crucial for the design of a large-scale web survey.
Je pensais à mes enfants qui regardent l'heure d'arrivée ou le temps qui reste, le kilométrage, parce qu'on peut le faire afficher sur certains, sur la plupart des modèles, je pense.
In 10 European countries, 8,000 persons, selected for being active drivers and users of in-vehicle technologies, have been questioned through a web-based survey. The questions were designed to learn more details about the population of IVT users, their characteristics, their motives to use the systems, and the benefits they perceive from the system use. The Interaction project aimed at developing its own autonomous data acquisition system. This system requires an auxiliary battery charged directly by the vehicle to reinforce itself. A GPS is coupled with a GPRS modem to locate the vehicle and transmit messages about the status of the acquisition system. An embedded PC collects the data from various sensors and cameras. The system is contained in a closed box to avoid any equipment tampering, while allowing the safe use of the trunk by the participants. The CTAG Event Manager collects data from sensors and transmits them to the PC. These sensors are positioned on the control devices and in-vehicle technologies to identify the driver's actions. 4 cameras are placed in the cockpit to observe the behavior of the participant, the front view, the dashboard information, and the navigation system. These cameras are connected to a video grabber card integrated in the PC. Once installed in the vehicle, the data acquisition system has to be tested and validated. It has to be autonomous, which leads to a certain complexity. A magnetic contact sensor is used to start data collection automatically when the door is opened. The PC starts and runs RT Maps software developed by Intempora, which automatically activates the data acquisition. These data are stored and synchronized reliably using diagram software developed specifically for the project. The camera views allow a subsequent coding of the use of in-vehicle technologies by the participants in a situation of naturalistic driving. The cameras are equipped with infrared LEDs to capture the environment regardless of the lighting conditions. After stopping the vehicle, the system remains active for several minutes, so as to avoid losing data. Then, if no movement or action from the driver is detected, it stops the data acquisition and turns off automatically. Once the data acquisition system is tested and validated, the on-road studies can begin.
On va vous demander de conduire la voiture sans changer vos habitudes de conduite. Vous devrez mettre le régulateur et le limiteur. On vous dira quand le mettre. Vous choisissez la vitesse et vous pouvez le mettre en pause si besoin. Pendant le parcours, vous recevrez 2 appels téléphoniques. On vous demande d'y répondre via le kit main libre.
D'accord, ça me paraît clair.
Eh bien, en voiture.
Dans un premier temps, on va juste sortir du site. Pour l'instant, vous allez suivre les indications qui sont données par le GPS.
Ok.
This observation grid was adapted from the Vienna driving test. It has been specifically designed to assess the possible effects of the IVT on the driver behavior and to detect modifications of the interaction between the driver and other road users.
Après 200 mètres, tenez la gauche, puis au rond-point, tournez à gauche, 4e sortie, tenez la gauche.
2 observation rides have been carried out with each test person. For both observations, the same standardized route with the same traffic situations was used. The test route was divided into 4 main sections, 1 for each IVT. An urban area for the navigation system, rural roads with light traffic for the mobile phone, rural roads and urban areas for the speed limiter, and motorways for the cruise control.
Ensuite, toujours l'aéroport Saint-Exupéry.
Oui.
During one observation ride, the driver was asked not to use any system. During the other observation ride, the driver had to use the IVT and to answer a phone call.
Oui, bonjour monsieur. Alors, citez-moi 5 à 10 marques de voitures.
Peugeot, Renault, Opel.
The aim of this observation was to investigate possible changes in the driving behavior between the 2 observation rides.
On va maintenant se garer devant le garage.
At the end of each observation ride, a debriefing session was planned in order to consolidate what had been observed during the ride.
Dont vous voudriez parler.
Donc c'est cette voiture que je vais utiliser pour mes trajets?
Tout à fait, c'est cette voiture que vous allez utiliser pendant 5 semaines sur
D'accord.
vos trajets habituels, aller faire les courses, aller au travail, aller chercher les enfants à l'école. On vous demande d'utiliser les systèmes comme vous l'auriez fait avec votre propre voiture, ni plus ni moins.
D'accord.
Très bien. Bonne route.
Merci, à
Au revoir.
bientôt. Au revoir.
"70 participants have been monitored in real driving conditions. 5,000 hours of driving data have been collected. Data analysts have been working on this database in order to identify the context of use of the systems. When and where do drivers choose to engage or disengage speed regulation systems? Do they favor specific driving conditions to make a phone call?
Oui, c'est moi. Écoute, je suis arrivé au magasin, là, j'en ai à peu près pour un quart d'heure, et puis je te rappelle. Allez, à tout à l'heure.
Some of the interactions cannot be directly measured, and experts have been reviewing the videos in order to enrich the data. They have coded aspects of the IVT use and the context in which drivers choose to use the systems.
Le codage de données sert tout d'abord à répertorier toutes les situations rencontrées par les participants durant l'expérience, ensuite d'enrichir les données brutes que l'on va récupérer, et donc au final pour confirmer ou infirmer les hypothèses que l'expérience soulève. Nous procédons vidéo par vidéo avec 4 types de codage différents. Donc, tout d'abord les conditions de circulation avec le trafic, les conditions de lumière et les conditions météo. Ensuite nous avons le système de navigation, donc le GPS. Ensuite le régulateur limiteur de vitesse et pour finir le téléphone portable. Nous nous intéressons au début et à la fin de certaines situations, comme par exemple le début d'un appel et la fin de celui-ci, le début d'une situation complexe de trafic et le retour à la normale, ou encore le début de mise en marche du régulateur ainsi que la vitesse à laquelle il est actionné et la fin de cette utilisation. Une fois codées, les données sont placées sur un serveur pour ensuite être analysées et complétées par des analyses statistiques.